Have you ever stopped to think about the math behind, say, choosing your pizza toppings, or setting a password, or even just trying to arrange your friends for a group photo? Well, it all comes down to this one really cool idea: combinatorics. And believe it or not, it's not some scary abstract math concept. It's the secret logic behind counting all the possibilities in our world. So let's break down how it works. To really get what I'm talking about, let's just dive right in with a simple puzzle. Forget about formulas in big math terms for a second. Let's just use our intuition. Okay, here's the deal. You've got 3 friends, Jay, Ted, and Ken. You need to line them up for a picture. So how many different lineups can you actually make? Just take a second and think about it. Well, we could just, write them all down. We could start with Jay, then Ted, then Ken. Or we could keep Jay in the first spot and just swap Ken and Ted. Then we could do the whole thing over again, but starting with Ted. And then again, starting with Ken. Now, this works okay for 3 people, but you can already feel how this would be a total nightmare with a bigger group, right? So, after listing them all out, we find there are exactly 6 possible arrangements. Easy enough for 3 friends, I guess. But what if you had 10 friends, or 50? Listing them all out would be pretty much impossible. There's got to be a better way, a mathematical shortcut. And that shortcut? Well, it all hinges on one really, really important idea. The method we use depends entirely on one simple thing: whether the specific order of the items actually matters. And boom, that brings us to our first big idea: a permutation. A permutation is just a fancy name for any arrangement where the order is super important. In our photo puzzle, J, Ted, Ken is a completely different picture from Ken, Ted, J, right? The order created a unique result, and that's what makes it a permutation. I mean, think about a PIN code. The digits 4, 5, 6, and 7 are the same, but the order you punch them in makes all the difference. One order gets you into your account, the other gets you locked out. In a situation like that, order is absolutely everything. And that, right there, is exactly why we can't just list possibilities. For things like passwords or PINs, we need a reliable shortcut, a formula that can handle any situation where order is king. And this is the tool for the job, the permutation formula. Instead of writing out endless lists by hand, this powerful little formula calculates the number of unique arrangements for us, especially when every single position matters. Let's run through a few more examples just to make sure this really clicks. Awarding gold, silver, and bronze medals in a race? Oh yeah, that's a permutation, because first place is way different than third. Creating a computer password? Absolutely a permutation. And electing a chairman and a co-chairman? The roles are different, so the order you pick them in creates a totally different outcome. Okay, so this is where it gets really interesting. What happens when this super powerful tool just doesn't work? Yep, there are situations where using a permutation actually gives you the wrong answer. Let's look at a twist that creates a big problem. So let's switch gears. Imagine a new scenario. We have 10 people, and we're giving out 3 prizes. But this time, all the prizes are identical, 3 crisp $5 bills. How does that change things? Can we still use our trusty permutation tool? Well, think about it. With distinct prizes, like 20, 10, and $5, giving Jay the 20 is a unique outcome. The order matters a lot. But with identical $5 prizes, who cares if Jay is picked first or third? No one. He still gets $5. It's like all those different arrangements we counted before suddenly collapse into the exact same outcome. Jay, Ted, and Ken each get $5. So, if we just blindly plug this into our permutation formula, it would spit out the number 720. But we know that's totally wrong. It's counting every single different order as a unique outcome, when in reality, they're all the same. This is what we call overcounting, and we need a way to fix it. So how do we fix that overcounting problem? We need a new tool, one that's specifically designed for situations where the order of selection is completely and totally irrelevant. And that tool, my friends, is called a combination. A combination is all about the selection, where order doesn't matter one bit. It's about the group you select, not the order you select them in. So choosing 3 friends to go to a concert is a combination, because it doesn't matter who you asked first, second, or third, the same 3 people are going to the show. Now, take a look at the formula for combinations. You see that extra little piece in the bottom, that R factorial? That's the secret sauce. That's the magic little bit of math that goes in and divides away all those duplicate arrangements that a permutation would have counted. It's the mathematical fix for our overcounting problem. Okay, This table really nails the difference. Electing a chairman and co-chairman is a permutation because the roles are distinct. But just choosing a three-person committee where everyone's equal, that's a combination. A password is a permutation. Choosing pizza toppings is a combination because a pepperoni, mushroom, and onion pizza is the same exact pizza no matter what order you say the toppings in, right? So after all that, you might be thinking this is kind of complicated. But the truth is, this whole thing, permutations, combinations, the whole shebang, it all comes down to asking yourself just one single, incredibly powerful question. And that question is, does order matter? That's it. That's the master key. Before you try to solve any of these problems, you just ask yourself, does the order of selection create a new, distinct outcome? Your answer tells you exactly which tool you need to use. So think of this as your new mental toolkit. It's a super simple 4-step process. 1. Read the problem. 2. Ask the golden question. 3. If the answer is yep, the order totally creates a different result, bam, you've got a permutation. And 4, if the answer is nope, it's the same group no matter how you pick them, then you need a combination. Seriously, that's it. So from now on, when you see someone choosing lottery numbers, or a dealer laying out a hand of cards at a poker table, or even a coach picking a team, ask yourself that question. Is this a permutation or a combination? You'll start to see this hidden layer of possibilities swirling around in these simple everyday moments. The math is everywhere once you know how to look for it.